Okay, thank you for having me. And today I will talk about Bazel and Monorepo. And who am I? I'm Quanyi Ma from Web3 Infrastructure Foundation, which foundation is established in Hong Kong in March of this year. The foundation aims to helping the open source project to build a Web3 infrastructure, and I'm also a Rust developer, a software architect, and you can reach me through the ID. Today is BazelCon, so I want to dive into the Bazel, as most of you are already familiar with the Bazel. Let's just recap some key features. First is Bazel is have intelligent dependency management and ensure only the parts which need to build a process which can cut the build times and saving times. And second is Bazel have incremental build and test, which means you don't need to rebuild and retest everything with each the code commit. Just 5 parts. 3 is parallel processing and is speed up the process. Is harmonious powers from the multiple core processors. Last is the remote caching and execution is ensures only if build is completed elsewhere is don't need to repeatedly. Is all the key feature, but while this is necessary, Bazel is engineered for the monumental build scalability, and if a small project such tools like GitHub Action or Jenkins are certified, when we talk about the large scale build, we usually refers to the extensive application and the microservice. So such vast system need to be built and test with each the code updates. So large vast code generally requires a large scale build. So if any team and organization utilize some technology like this, will be prepared to managing vast code base. So there is a two-way host our code base is a Monorepo and Polyrepo. So Monorepo is like the name suggests, is a single repository containing all the codes or projects or multiple related projects. Imagine an entire company's code base in one place. So this approach is offer a simplest way code sharing and collaboration across the team, maintaining the collaboration and will be easily. So it worth noting is the Monorepo has a scalability issue. So on the other hand, we have polyrepos. Polyrepos means each of the component or project has a separated repository, and this approach is managing a challenge when we have multiple projects and have the multiple dependency. When we completed, we will be faced up to date to the projects, and across the repository will be the dependency will be complex. So let's see the big company how to handle his Monorepo. Google has a repository it has a system named Pepper, and Pepper already as January 25. Pepper has 16 terabyte count and 1 million, 35 million commits and 1 billion files. So Pepper is based on the Google infrastructure spanner across the 10 data center all over the world. And for now, Google Pepper is not open source. So let's see, Facebook. Facebook has a client is named Sapling. is already open source, and he has a Monorepo server is named Mononoke. It's familiar, it's interesting, and the Zeppelin and the Piper always use the database as a backend. It's different. Is Zeppelin use some file system is a hyper backend. So Microsoft has a client has an open source named Scalar. Scalar is helping the developer manage Monorepo in the client side. So you can use this feature, manage a large repo, but Scalar is based on the GVFS protocol, is a Git virtual file system protocol, but there's no open source server based on the GVS server. So you can use a client. Git is already the most version control system in the world. So when we use Git, we want to also use the Monorepo. How we do is Git has two native filter. First is submodule. Submodule means looks like a one-way link. So we can't update the module, submodule in the mono repository, is only can update in the separate. So Git provide another filter is means subtrees is a two-way link, so you can update in the mono repository and submodules. So whatever tools is already have a challenge of manage dependency. You can think is you have a nice structure, and repository A have a submodule B, and the submodule B has a submodule C. It will be lead to chaos. So how we do, and we inspired by the Google Piper, so we decode the Git. We sort the Git into the database. So use the distributed database to support a monorepo structure. So we must to know what's the Git internal objects. Git is a addressable content file system, and also is a database. They have three objects. The first is a blob and a tree, and the blob is a content. It's just like a container. When you push when you commit a file into the Git, is into a blob. So when you the same file you modified and commit again, will be two of blob. So Git is a snapshot version control system. Also, Git has another object is named tree. It has 4 tree types, as this is only shows the 2 types. Is one type tree types pointed to the blob, and one time to the pointed to the another tree. So it's present a dictionary or all the repository. And so we design substructure with Rust. And another thing is a single nature. Single nature is will be in the Git commit and the Git tag. Is show who and why, and just the who and the email when make the change in your repository. Git commit is the core in the Git. They have 2 is must be point is the parent is the tree. So Git is the committer has a tree ID and point to the tree object. So when you commit is a point the snapshot of the repository, and also Git has a parents tree ID. So means you have a different paths from the fathers. In the usually we use the Git branch. So like the Git merge will be have the mutable parent. So this is a signature, and this message you can see why and how fixed in this commit. The last is Git has a annotated tag. Actually, Git has 2 types like is one is an NFT tag, and second is the lightweight tag. Lightweight tag has no the metadata. So, the identity tag has a type is pointer to the commit. So tag looks like a constant static variable in the language. Is usually we have the a branch like a dynamic is a label. So this is all the 4 objects in the Git. So we encode and decode so we can save it to the database. So like this, we save all the object to the 2 object is 2 database is named object and commit, and we will be analysis to the another table is node, so we can map all the repository. So we can use the distributed database host a very large repository. And when we do that, we design a very simply architect. We just had 2 levels, 2 layers. First, we rewrite the HTTP gateway and the SSH gateway in Rust, and the second is into the database. When we do that, we notice the Git actually has a 2 protocol. The old one is a dump protocol. Is means you push and get the object one by one, and for now actually use the smart protocol. Is means he pack all the objects into a file and push to the gateway. So we must decode and another file. So it's look like this. Okay, it's just my theory, but how it's work. So let's see a demo. Yeah. So this creator database is last night I'm testing for. I already inserted 22 million files in a database in a single repository. This is from the Rust creator repository. I almost 20,000 repository. I imported this repository to a single Git. So let's see from the beginning how to use the system. So for now has 2 database. Is last database is I trust test. A single is another is a test. So let's drop it. Okay, it's a new database. So let's initial the database structure. Okay, and for now I must create a new user for this. Drop it. Drop create user. Okay, so I grant the privilege. So now, I must initial the database. So there will be create three folder in the database. So for now, run the HTTP service, and it's okay. So let's see GitHub remote. So there's a local and already ready. So let's git push the local main to the mega. The project named the mega. So we can see we decoded all the objects into the database. So let's see. So already okay. So let's clone from the other way. So so let's close this one. This one. So it's already clone a new project, so we can go build. Yeah, so we copy the configure file. We run again. Yeah, it's okay. It's already start. So let's clone another repository. Okay. Let's see. The UI is the folder in the repository, so we can clone any folder in entire the repository. So let's try something like the gateway and the SRC. Yeah, so you can clone anything. So if you have a monorepo, you just clone any level folder into the local as the Git repository. So let's see the UI install. Let's see a very ugly UI. It's still have many bugs. So let's see is it's just a simple UI. You can see everything in the repository. And for now, For now, let's see. There's only one committed history in the local repository. Let's see why. Okay. So we have limited the sorry. So we have limited to the used mega is a monorepo. First, we have you only can use one branch is named main. Second is each you commit you only have the one commit in the pack. And three, we don't allow the developer use the tag. So we will be provide a REST API to get the tag. When you release the you must use the UI or API. We not allow the developer use the git command to do that. So the last is Mega and Bazel. So for now we have the simplest we trigger the Bazel. For now, if you push the code and we will clone into a temporary dictionary and call the Bazel, and with the remote executor, so parameter, so to build. Let's see the last demo. And same thing. It's okay. So let's see the master container. Start a build farmer. Yeah, it's okay. So let's see, make the change. So let's copy the cargo Bazel log file. And, oh, sorry. I must modify the. So yeah. So we run the service again and so let's change some code. And hello Bazel come. Now let's see the build farmer worker temple dictionary. For now, is nothing in there. We commit. And for now, we'll be clone the project into a temporary in the temple, so will be called Bazel. Will be called the Bazel farmer. So it's the output. Yeah. Yeah, it's a start to build the target. Just sorry, it's not working. It doesn't matter. Just call the build farm. So for now, we just complete the prototype phase, so we can encode and decode everything. So next phase we will be working on the UI and the user system. In the future, we will be want to the fuse system like the Microsoft Scalar, and you can mount and connect to the remote repository. And we also have a joint project with Zhongnan University in China. We are working on the looking for a way to resolve the large language model version control. So if you're interested, you can try. So that's all. Thank you. Oh yeah. Any question?
How is this different from partial clone?
Oh yeah. So if you did partial clone, means you must clone all. You must clone with all the Git structure. When you using it, will be get the from the repository. It's just I think it's how can I see it's a partial clone. If you must clone from the root repository. When we do that, we can clone any level folder in the repository.
Well, that's fast check out. Right? For you can check out a specific directory. But partial clone just means that you can you please yeah, so partial clone part is to reduce the download, and the spot checkout part is to reduce the number of files that's visible to user. And I guess it looks like almost the same as.
It's not the same. If you partial clone, is you must have the entire the Git database, the structure into local. When we use the mega clone any folder, we will be fake Git structure to you, so you can use any folder. It's a difference. So if you use the partial clone, you must clone from the top level, the root, the top of the level. And when you're using like some scalar or the sapling, when you're using it, will be have the file monitor system. You can they will be help you to clone from the repository from the server. I think it's different. Yeah. Thank you.
Thank you for the talk.